They stood in silence, German prisoners of war, staring through the chain-link fence at something their minds refused to accept. Every 63 minutes, a 4-engine bomber, complete, fueled, and ready for combat, rolled out of the massive building before them. Their officers had told them it was American propaganda, an elaborate hoax designed to break their morale. But here, in the flat Michigan countryside, the impossible was happening. One B-24 Liberator every hour. The war they thought they understood had just revealed a terrifying truth. They had never stood a chance. The autumn of 1940 painted a grim portrait across Europe. Nazi Germany's Luftwaffe dominated the skies, and Britain stood alone against the relentless tide of fascism. Across the Atlantic, President Franklin D. Roosevelt understood what many Americans did not yet grasp. The United States would inevitably be drawn into this global conflagration. And when that moment arrived, the nation's industrial capacity would determine victory or defeat. The challenge facing American military planners was staggering in its complexity. The consolidated B-24 Liberator bomber, a 4-engine heavy bomber capable of striking deep into enemy territory, represented the cutting edge of aerial warfare. Each aircraft contained 480 193 individual parts, assembled into 30,000 components, organized into 24 major subassemblies. The bomber stretched 67 feet in length, with a wingspan of 110 feet and weighed 36 tons when fully loaded. Consolidated Aircraft's San Diego facility could produce approximately one B-24 every day, an impressive feat by any standard. But Roosevelt's vision demanded something unprecedented. He called for 50,000 aircraft per year, a number that seemed to defy the laws of physics and economics. The existing aircraft manufacturers, skilled craftsmen working in traditional aviation facilities, could never meet such astronomical demands. The president needed a miracle, and he needed it from an unlikely source: the automobile industry. In January 1941, William Knudsen, former president of General Motors and now director of the Office of Production Management, approached Henry Ford with an audacious proposal. Ford Motor Company, the pioneer of assembly line manufacturing, would build B-24 bombers using automotive production techniques. The initial request was modest: manufacture components for Consolidated's assembly. But Charles Sorensen, Ford's vice president of production, saw something more ambitious. After visiting the San Diego plant and studying the B-24's construction, Sorensen returned to Detroit with a radical proposition that would change the course of the war. "We'll build the complete airplane," Sorensen declared to a skeptical Henry Ford. "One per hour." The statement was met with disbelief, not just within Ford Motor Company, but across the entire aviation industry. Aircraft manufacturing was an art, not a science, or so the conventional wisdom held. Each plane was essentially handcrafted by skilled workers who understood the nuances of aeronautical engineering. The idea of applying automotive mass production techniques to something as complex as a 4-engine bomber struck many experts as dangerously naive. The skepticism had merit. Automobiles, even the most sophisticated models, contained perhaps 15,000 parts. The B-24 had more than 30 times that number. An automobile operated on roads. A bomber had to maintain structural integrity at 25,000 feet while carrying 8,000 pounds of bombs and defending itself against enemy fighters. The tolerances were measured in thousandths of an inch. A single mistake could doom an entire crew. Yet Sorensen possessed an unshakable confidence born from decades of manufacturing experience. He had helped Henry Ford perfect the moving assembly line that revolutionized automobile production. He understood that complexity could be conquered through systematic organization, standardization, and the relentless application of efficiency principles. The challenge wasn't the bomber itself. It was the thinking that surrounded aircraft manufacturing. The site chosen for this unprecedented experiment was a tract of farmland near Ypsilanti, Michigan, approximately 30 miles west of Detroit. The location, known as Willow Run, offered flat terrain suitable for both factory construction and aircraft testing. In April 1941, construction began on what would become the largest room under one roof in the world, a factory stretching 3.5 million square feet, with an assembly line running more than a mile in length. The architectural specifications alone revealed the audacity of the project. The main building measured 3,200 feet long and 1,280 feet wide, with a ceiling height of 35 feet to accommodate the B-24's vertical stabilizer. The factory would require its own power plant, water treatment facility, and fire department. More than 42,000 workers would eventually labor within its walls, working 3 shifts around the clock, 7 days a week. But the physical structure represented only the beginning of the challenge. Sorensen and his team faced a fundamental problem: how to transform a craft-based manufacturing process into a continuous flow production system. At Consolidated San Diego plant, workers moved around stationary aircraft, installing components in whatever sequence seemed most practical. Willow Run would reverse this paradigm entirely. The aircraft would move, and the workers would remain stationary, each performing specialized tasks as the bomber progressed down the line. The engineering obstacles seemed insurmountable. The B-24's wing, for instance, measured 110 feet across, too wide to fit through standard factory doors. Sorensen's solution was characteristically bold. The wings would be built in sections, transported to the main assembly line, and joined to the fuselage in a carefully choreographed sequence that required millimeter precision. Any deviation would render the aircraft unflyable. Then there was the problem of the workforce. Automobile workers understood engines, transmissions, and chassis construction. They knew nothing about aeronautical engineering, hydraulic systems for bomb bay doors, or the complex electrical systems that powered a bomber's defensive armament. Ford would need to train tens of thousands of workers in skills that typically required years of apprenticeship, and they would need to do it in weeks. The skeptics multiplied as construction progressed through 1941. Aviation industry experts toured the rising structure and shook their heads. Will Run became the derisive nickname, a play on Willow Run that suggested the project would fail spectacularly. Newspaper columnists questioned whether Ford's automotive expertise translated to aircraft manufacturing. Some military officials privately doubted whether the investment would yield results before the war ended. Charles Lindbergh, the legendary aviator and aviation consultant, visited Willow Run in late 1941 and expressed cautious optimism tempered with concern. "The scale is impressive," he noted in his diary, "but scale alone does not guarantee success. An airplane is not an automobile with wings." Henry Ford himself, now 78 years old and increasingly removed from day-to-day operations, vacillated between confidence and doubt. His son, Edsel Ford, serving as company president, became the project's internal champion, fighting to secure resources and deflect criticism. The younger Ford understood what was at stake: not just the company's reputation, but potentially the outcome of the war itself. As 1941 drew to a close, Willow Run remained an enormous construction site, a promise unfulfilled. The factory's skeleton rose from the Michigan farmland, but no bombers emerged. The assembly line existed only in blueprints and the minds of Ford's engineers. Then, on December 7, 1941, Japanese aircraft attacked Pearl Harbor, and the United States entered World War II. The theoretical challenge had become a desperate necessity. America needed bombers, and it needed them immediately. The pressure intensified exponentially. Military planners projected that the combined bomber offensive against Germany would require thousands of heavy bombers to achieve strategic objectives. Every month of delay meant more Allied casualties, more cities destroyed, more ground that would need to be retaken at terrible cost. Willow Run had to succeed because failure was unthinkable. The first B-24 Liberator emerged from Willow Run on September 10, 1942, 15 months after construction began. It should have been a moment of triumph. Instead, it revealed the enormous gap between ambition and execution. The bomber was incomplete, requiring hundreds of hours of additional work at a separate facility before it could be deemed airworthy. The promise of 1 aircraft per hour seemed like a cruel joke. The winter of 1942 to 1943 became known within Ford as the season of reckoning. The massive assembly line, designed for seamless efficiency, stuttered and stalled with maddening regularity. Components arrived out of sequence. Tools, designed for one task, proved inadequate for another. Workers trained for weeks still struggled with the complexity of aircraft systems that bore no resemblance to automobile manufacturing. The physical environment itself presented challenges that automotive factories never encountered. The Michigan winter turned Willow Run into a frigid cavern where workers' breath formed clouds and metal became painfully cold to touch. Heating a building of 5 million square feet proved nearly impossible. Workers wore multiple layers of clothing, which restricted movement and made precision work even more difficult. Absenteeism soared as illness spread through the workforce. Logan Miller, a former automotive line supervisor now managing a section of the bomber assembly, faced a crisis that epitomized the broader struggle. His team was responsible for installing the B-24's complex hydraulic system, miles of tubing that controlled everything from landing gear to bomb bay doors. In automobile manufacturing, hydraulic systems were relatively simple: brake lines, power steering, perhaps a convertible top mechanism. The B-24's hydraulic system operated under pressures exceeding 1,500 pounds per square inch and required absolute precision. A single leak at altitude could prove catastrophic. "We're losing 3 days per aircraft just on hydraulic installation," Miller reported to his superiors in December 1942. "The workers can't see the connection points in the confined spaces. The tubing bends don't match the specifications. We're essentially rebuilding every system by hand." The problem wasn't limited to hydraulics. The electrical system contained over 15 miles of wiring per aircraft, with thousands of individual connections. A single reversed polarity could destroy sensitive equipment or, worse, cause an in-flight fire. The workers, accustomed to the relatively straightforward electrical systems of automobiles, struggled with the complexity. Error rates exceeded 30% on initial installations, requiring complete rewiring that consumed precious time. Mildred Hatcher, one of the thousands of women recruited to fill positions left vacant by men entering military service, worked on the electrical assembly team. She had been a telephone switchboard operator before the war, experience that supposedly qualified her for aircraft wiring. The reality proved far more demanding. "They gave us 3 weeks of training," she would later recall. 3 weeks to learn what aircraft electricians studied for years. "We had diagrams that looked like spider webs, with color codes that meant life or death for the crews who would fly these planes. I went home every night terrified that I'd made a mistake that would kill someone." The pressure on the workforce was relentless and multifaceted. Beyond the technical challenges, Willow Run faced a severe labor shortage. The factory's location, 30 miles from Detroit with limited public transportation, made commuting difficult. Housing near the plant was virtually non-existent. Workers endured 2-hour commutes each way, arriving exhausted and leaving depleted. Turnover reached crisis levels, with some months seeing 40% of the workforce quit or transfer to more accessible facilities. Ford's management responded with characteristic determination. They established a bus system that transported workers from Detroit and surrounding communities. They built temporary housing near the plant, crude dormitories that offered little comfort but reduced commute times. They increased wages and offered bonuses for perfect attendance. Still, the labor crisis persisted. The technical obstacles seemed to multiply faster than solutions could be implemented. The B-24's nose section, a complex assembly of plexiglass metal framing, and the Norden bombsight mounting proved particularly troublesome. The curvature of the plexiglass panels required heating and forming techniques that Ford's workers had never encountered. Early attempts resulted in panels that cracked under stress or distorted optical clarity, unacceptable for bombardiers who needed perfect visibility. Charles Sorensen, watching his grand vision stumble, refused to accept defeat. He implemented a strategy of controlled chaos, bringing in specialists from Consolidated Aircraft to work alongside Ford engineers, creating hybrid teams that combined aeronautical expertise with manufacturing efficiency knowledge. These teams identified bottlenecks and redesigned processes with ruthless pragmatism. One breakthrough came from an unexpected source. A young engineer named Joseph Galam, who had worked on the Model T's design decades earlier, observed that the wing assembly process required workers to climb inside the wing structure to install internal components, a time-consuming and physically demanding task. Galam proposed a radical solution: build the wing in two halves, install all internal components while the structure was open and accessible, then join the halves with a precision riveting process. The technique reduced wing assembly time by 40%, but for every problem solved, two more emerged. The bomber's four Pratt & Whitney R1830 engines, each producing 200 horsepower, arrived from external suppliers on unpredictable schedules. When engines were delayed, partially completed aircraft accumulated on the assembly line, creating bottlenecks that cascaded through the entire system. Ford had no control over engine production, yet the entire operation depended on their timely delivery. Weather added another layer of complexity. The spring of 1943 brought torrential rains that turned the unpaved areas around Willow Run into muddy quagmires. Trucks delivering components became stuck. Workers trudged through ankle-deep mud to reach the factory entrance. The airfield where completed bombers underwent test flights became unusable for weeks, forcing Ford to transport aircraft to alternative locations. A logistical nightmare that consumed resources and time. Inside the factory, the sheer scale of the operation created communication challenges that no one had anticipated. A problem identified at one end of the mile-long assembly line took hours to communicate to the other end. Supervisors spent more time walking between stations than actually supervising. Ford installed a telephone system with hundreds of extensions, but coordinating activities across such vast distances remained a constant struggle. The quality control crisis reached its peak in March 1943. Army Air Force's inspectors rejected 17 consecutive aircraft for defects ranging from improperly installed fuel tanks to misaligned control surfaces. Each rejection was a blow to morale and a stark reminder that lives depended on perfection. The military threatened to cancel the contract and redirect resources to other manufacturers who, while slower, produced consistently acceptable aircraft. Edsel Ford, his health deteriorating under the stress, personally intervened. He established a new quality control protocol that placed inspectors at every major assembly station rather than only at the end of the line. Defects would be caught and corrected immediately, not after an entire aircraft had been completed. The change slowed production initially, but dramatically improved acceptance rates. Yet, even as solutions emerged, the human cost mounted. Workers collapsed from exhaustion. Accidents increased as fatigue degraded concentration. A riveter named Thomas Chen lost 3 fingers when a pneumatic tool misfired. A welder named Sarah Morrison suffered severe burns when a fuel line she was installing ruptured. The factory's medical facility, originally designed to handle minor injuries, evolved into a full-scale hospital treating dozens of workers daily. By May 1943, Willow Run was producing approximately one B-24 per day, a significant achievement, but nowhere near the promised one per hour. The factory had consumed over $200 million in construction and equipment costs, employed 42,000 workers, and generated intense scrutiny from Congress, the press, and military leadership. Critics called it "Will It Run?" and questioned whether Ford's experiment had been a catastrophic miscalculation. Charles Sorensen, now 62 years old and bearing the weight of the project's struggles, stood on the factory floor one evening in late May, watching the assembly line move with agonizing slowness. He had built his reputation on efficiency and results. Willow Run threatened to destroy that legacy. But Sorensen possessed something that statistics and critics couldn't measure, an unshakable belief that the system would work if given time to mature. The question was whether time remained before patience and funding ran out. In the spring of 1943, a peculiar pattern began appearing in German intelligence reports flowing into the Oberkommando der Wehrmacht headquarters in Berlin. Luftwaffe reconnaissance flights over England were documenting an inexplicable increase in American B-24 Liberator bombers stationed at Royal Air Force bases. The numbers didn't align with German projections of American industrial capacity. Oberst Heinrich Wegener, a veteran intelligence analyst with the Luftwaffe's Foreign Armies West Division, studied the reconnaissance photographs with growing confusion. His calculations, based on pre-war assessments of American aircraft manufacturing, predicted a maximum of 150 to 200 B-24s arriving in the European theater per month. Yet the photographic evidence suggested nearly double that number. His initial reports were met with skepticism from his superiors. The Americans are moving the same aircraft between bases to create an illusion of strength, suggested General Major Kurt Dressler, dismissing Wegener's analysis. It's a psychological operation, nothing more. We know their industrial capacity. They build automobiles, not complex military aircraft. This is propaganda. The German military leadership's confidence rested on a foundation of doctrinal assumptions that had served them well in the early war years. German industry prioritized quality over quantity, producing sophisticated weapon systems through skilled craftsmanship. The Messerschmitt Bf-109 fighter, the backbone of the Luftwaffe, required approximately 5,000 man-hours to complete. Each aircraft was a testament to German engineering excellence, built by workers who understood every nuance of aeronautical design. The notion that Americans, whom German propaganda portrayed as culturally inferior, obsessed with mass-produced mediocrity, could manufacture heavy bombers at rates exceeding German production, seemed to violate the natural order. Albert Speer, Reich Minister of Armaments and War Production, had toured American automotive factories before the war and came away impressed by their efficiency, but dismissive of their ability to transition to military production. Americans excel at making thousands of identical items, Speer had written in a 1938 report. But military equipment requires precision, adaptability, and engineering sophistication that mass production cannot achieve. Their automotive techniques are irrelevant to warfare. This assessment, widely accepted within German military circles, created a cognitive barrier that prevented accurate interpretation of the intelligence emerging from the European theater. When Luftwaffe pilots reported encountering larger formations of B-24s during bombing raids over Germany, their accounts were attributed to the chaos of combat rather than actual increases in enemy strength. Hauptmann Franz Steigler, a decorated fighter pilot with 28 confirmed kills, experienced this disconnect firsthand during a mission over Bremen in June 1943. His squadron of Bf-109s intercepted a formation of B-24s that seemed to stretch across the horizon. "There were at least 60 bombers in that formation," he reported during debriefing. "Perhaps more. I've never seen American formations of that size." His commanding officer, a veteran of the Battle of Britain, shook his head. You're overestimating due to combat stress, Hauptmann. The Americans don't have 60 bombers to spare for a single raid on Bremen. Perhaps 30, appearing as 60 in the confusion of battle. But Stigler knew what he had seen. More troubling than the numbers was the condition of the aircraft. German intelligence had reported that American bombers often showed signs of hasty construction, mismatched paint, visible repair work, inconsistent markings. These B-24s appeared uniform, almost identical, as if produced by some vast mechanical process rather than assembled by human hands. It was a detail that nagged at him, a piece of evidence that didn't fit the accepted narrative. In Berlin, the intelligence reports accumulated into a pattern that could no longer be easily dismissed. By July 1943, German analysts estimated that American bomber strength in England had increased by 400% since the beginning of the year. The numbers were impossible according to every pre-war assessment of American industrial capacity. Wegener prepared a comprehensive analysis that challenged the prevailing assumptions. He obtained production figures from neutral sources, cross-referenced them with reconnaissance data, and arrived at a conclusion that seemed absurd. The Americans were producing heavy bombers at a rate of at least 15 per day across all manufacturers. If accurate, this meant American production exceeded German bomber production by a factor of 10. His report was forwarded to Reichsmarschall Hermann Göring, commander of the Luftwaffe, who read it with mounting anger. Göring had built his reputation on the Luftwaffe's superiority and had repeatedly assured Hitler that American industrial capacity posed no serious threat. Wegener's analysis, if correct, meant that Göring's assurances had been catastrophically wrong. "This is defeatist nonsense," Göring declared during a staff meeting in August 1943. "The Americans are incapable of such production rates. They lack the skilled workforce, the engineering expertise, and the industrial discipline. This report assumes they've somehow revolutionized aircraft manufacturing, which is impossible. I want a full investigation into how such alarmist propaganda infiltrated our intelligence services." Wegener was reassigned to a minor administrative position. His analysis was filed away, marked as unreliable. The German High Command continued operating under assumptions that were increasingly divorced from reality. Yet the evidence continued mounting in ways that couldn't be entirely suppressed. Luftwaffe maintenance crews examining captured or crashed B-24s began noticing peculiarities in their construction. The aircraft showed signs of standardization that seemed impossible for hand-built machines. Rivet patterns were identical across different aircraft. Component serial numbers suggested production runs in the thousands. Most puzzling were the manufacturing stamps found on internal structures. Ford Motor Company, Willow Run plant. A technical intelligence officer named Major Klaus Richter became obsessed with these markings. Ford was an automobile manufacturer. The idea that they were building bombers seemed preposterous, yet the evidence was undeniable. Richter obtained pre-war literature about Ford's manufacturing techniques and began developing a theory that his colleagues found laughable. What if the Americans have applied automotive assembly line techniques to bomber production? He proposed during a technical briefing in September 1943. What if they're building aircraft the way Ford builds automobiles, on a moving assembly line with specialized workers performing repetitive tasks? The room erupted in derisive laughter. A senior engineer from Messerschmitt stood and delivered a withering response. "Major Richter, an automobile has perhaps 15,000 parts. A heavy bomber has 500,000. The complexity is incomparable. Assembly line techniques work for simple, repetitive products. Aircraft require skilled craftsmen who understand the entire system. Your theory violates every principle of aeronautical manufacturing." Richter persisted, but his voice was drowned out by institutional certainty. The German aviation industry had pioneered many advances in aircraft design and manufacturing. The notion that Americans, relative newcomers to military aviation, had discovered a revolutionary production method that German engineers had overlooked was too humiliating to contemplate. Meanwhile, German cities were experiencing the consequences of this willful blindness. The combined bomber offensive intensified throughout 1943, with American bombers appearing in ever larger formations. Hamburg was devastated in July. The Schweinfurt ball-bearing factories were targeted in August and October. Each raid involved hundreds of bombers, and the Americans seemed capable of replacing their losses almost immediately. Luftwaffe fighter pilots, the elite of the German military, began expressing private doubts about the war's trajectory. They were shooting down American bombers at impressive rates, sometimes 20 or 30 in a single major engagement. Yet the next raid would feature just as many bombers, as if the losses had never occurred. It was psychologically devastating, like fighting an enemy that could regenerate infinitely. Lieutenant Werner Schröer, after shooting down his 40th Allied aircraft, confided to his diary, "We are winning every battle and losing the war. For every bomber we destroy, 2 more appear. Where are they coming from? How can the Americans replace their losses so quickly? It defies logic." The answer to Schröer's question was rolling off the Willow Run assembly line at an accelerating pace. But German intelligence remained trapped in a paradigm that made the truth invisible. Their pre-war assessments, their doctrinal assumptions, and their cultural prejudices had created a blind spot that prevented them from recognizing the revolution occurring in American manufacturing. By the end of 1943, some German officers were beginning to suspect the truth, but by then it was too late. The industrial might that they had dismissed as impossible was already reshaping the war's outcome. The perplexity that had characterized German intelligence analysis was giving way to a more terrible realization. They had fundamentally misunderstood their enemy's capabilities, and that misunderstanding would cost them everything. In the frozen winter of 1943, as German forces retreated on multiple fronts and Allied bombers darkened the skies over the Reich with increasing frequency, the question was no longer whether American production claims were propaganda. The question was whether Germany could survive the industrial avalanche that was about to bury them. The crisis that nearly destroyed Willow Run's promise arrived not from external enemies, but from within the factory's own success. By January 1944, production had accelerated to 1 B-24 every 4 hours, a remarkable achievement, yet still far from the 1 per hour goal. Then, on a frigid morning, the entire assembly line ground to a halt. The problem was simultaneously simple and catastrophic. The factory had outpaced its supply chain. Charles Sorensen received the news in his office at 6:47 a.m. The wing assembly section had run out of aluminum alloy sheets. The engine mounting stations lacked the specialized steel brackets required for Pratt & Whitney installation. The hydraulic system inventory had been depleted 3 days earlier than projected. Across the mile-long assembly line, workers stood idle beside half-completed bombers, waiting for components that weren't arriving. The root cause was a paradox of success. As Willow Run's efficiency improved, it consumed materials faster than suppliers could deliver them. The entire supply chain, designed for a production rate of 1 aircraft per day, couldn't adapt quickly enough to support the accelerating output. Aluminum suppliers in Pennsylvania were producing at maximum capacity. Steel mills in Ohio were already working triple shifts. The bottleneck wasn't at Willow Run, it was everywhere else. "We have 48 hours of inventory remaining across critical components," reported William Pioch, Ford's supply chain director, during an emergency meeting. "After that, we'll be forced to shut down sections of the line. If we can't resolve this within a week, we're looking at a complete production halt that could last months." The implications extended far beyond Willow Run. The 8th Air Force in England was planning Operation Argument, a massive coordinated assault on German aircraft manufacturing facilities scheduled for February. The operation's success depended on having sufficient bomber strength to overwhelm Luftwaffe defenses. Every day of production delay meant fewer aircraft available for the offensive, which translated directly into higher casualty rates for the crews who would fly the missions. Sorensen's response demonstrated the kind of radical thinking that had made Ford Motor Company an industrial powerhouse. If the supply chain couldn't keep pace with Willow Run, then Willow Run would have to create its own supply chain. Within 72 hours, Ford engineers were designing a massive expansion that would integrate component manufacturing directly into the Willow Run complex. The plan was audacious to the point of recklessness. Ford would build its own aluminum fabrication facility adjacent to the main assembly building. They would establish a steel processing plant capable of producing the specialized brackets and fittings that external suppliers couldn't deliver quickly enough. They would even manufacture their own hydraulic components, eliminating dependence on outside vendors for critical systems. The construction began while the existing assembly line continued operating on dwindling inventory. Workers arriving for their shifts witnessed a factory expanding in real time around them. New buildings rose from the frozen Michigan ground with astonishing speed. Equipment was installed and operational within days of arrival. The expansion consumed resources at a rate that made Ford's financial officers physically ill, but Sorensen had obtained a blank check from the War Production Board. Whatever Willow Run needed, Willow Run would receive. Rosemary Colt, a metallurgist recruited from the University of Michigan, found herself leading a team tasked with establishing the aluminum fabrication process. She was 26 years old, one of the few women in a technical leadership position, and she had exactly 11 days to create a functioning production line for aluminum wing panels. "We're not trying to match the quality of established suppliers," she told her team during their first meeting. "We're trying to exceed it while producing at triple their speed. Impossible is not an acceptable answer." Her team worked in shifts around the clock, sleeping in cots set up in a converted storage room. They experimented with new alloy mixtures that could be formed faster without sacrificing strength. They designed rolling mills that could process sheets in a single pass, rather than the traditional multiple passes. They invented quality control techniques that could inspect metal at production speeds that would have seemed insane weeks earlier. The breakthrough came from an unexpected source. A machinist named Robert Chen, who had emigrated from China in 1936, suggested adapting a technique he'd learned in his father's metalworking shop in Shanghai. By heating the aluminum to a precise temperature and using a specific rolling pattern, they could achieve in one operation what traditionally required three. The technique violated conventional metallurgical wisdom, but when tested, the resulting panels met or exceeded all specifications. "Sometimes the old ways are better than the textbook ways," Chen observed quietly, as his innovation was rapidly implemented across the new fabrication facility. While the supply chain crisis consumed attention, another threat emerged that could have ended Willow Run's operations permanently. In February 1944, a fire broke out in the paint and finishing section, a catastrophic scenario in a facility filled with volatile chemicals, magnesium components, and thousands of workers. The blaze started in a paint booth where a worker's welding torch ignited solvent vapors. Within minutes, flames were racing through ventilation ducts, spreading to adjacent sections. The factory's fire suppression system, designed for automotive manufacturing, proved inadequate for the unique hazards of aircraft production. Magnesium components, used extensively in the B-24 structure, burned with intense heat that water couldn't extinguish. The fire threatened to reach the main assembly line, where partially fueled aircraft would become massive bombs. Plant manager Logan Miller made a decision that saved the factory, but could have killed dozens. He ordered the activation of an experimental carbon dioxide flooding system that had been installed but never tested at full scale. The system would displace oxygen throughout the affected sections, suffocating the fire, but also creating a deadly environment for anyone caught inside. "Evacuate sections 7 through 12 immediately," Miller's voice boomed over the public address system. "All personnel, evacuate now. This is not a drill." Workers fled as alarms shrieked and emergency lighting activated. The carbon dioxide system engaged with a roar like a jet engine, flooding the affected areas with invisible gas. The fire died within 90 seconds, but 3 workers who had been trapped in a storage room lost consciousness from oxygen deprivation. They were rescued by emergency responders wearing breathing apparatus and survived, but the incident revealed how close Willow Run had come to disaster. The fire's aftermath forced a complete redesign of the factory's safety systems. Ford engineers, working with fire protection specialists from the National Fire Protection Association, developed new protocols specifically for aircraft manufacturing environments. They installed additional fire barriers, upgraded ventilation systems to prevent vapor accumulation, and created evacuation procedures that could clear the entire facility in under 8 minutes. Yet even as these crises were being managed, production pressures intensified. General Henry Hap Arnold, commanding general of the Army Air Forces, visited Willow Run in March 1944 with a message that was simultaneously encouraging and demanding. "You're doing the impossible, and now we need you to do more." Arnold explained that the planned invasion of Europe, Operation Overlord, would require air superiority on a scale never before attempted. The 8th Air Force needed to destroy the Luftwaffe's ability to contest the skies over Normandy. That meant more bombers, more raids, and more pressure on Willow Run to accelerate production beyond even the ambitious 1-per-hour target. Sorensen, now visibly aged by the strain of the previous 3 years, listened to Arnold's requirements and made a commitment that seemed to defy physics. Willow Run would reach 1 bomber per hour by May 1944 and would sustain that rate through the critical months leading up to the invasion. The final push required innovations that rewrote manufacturing doctrine. Ford engineers implemented a floating workforce system where workers could be rapidly reassigned to bottleneck areas. They developed predictive maintenance algorithms that could identify equipment failures before they occurred. They even redesigned certain B-24 components to simplify assembly without compromising performance, changes that Consolidated Aircraft had insisted were impossible. One innovation came from an assembly line worker named Dorothy Ellis, who had been a seamstress before the war. She noticed that workers installing the bomber's fabric control surfaces were using techniques borrowed from metalwork, which was inefficient. Ellis demonstrated sewing techniques that could install the fabric in half the time with superior results. Her methods were adopted across the entire control surface assembly section, saving precious minutes on every aircraft. By April 1944, the assembly line was moving with a rhythm that seemed almost organic. Components flowed from the new integrated supply facilities directly to installation points. Workers moved with practiced efficiency, their movements economical and precise. The mile-long factory had become a single organism, breathing life into aluminum and steel, transforming raw materials into instruments of war with relentless consistency. On May 1, 1944, at 2:17 p.m., a B-24 Liberator rolled off the Willow Run assembly line. 63 minutes later, another followed, then another. The impossible had become routine. Charles Sorensen stood on the factory floor, watching the bombers emerge at 1-hour intervals, and allowed himself a moment of satisfaction. They had conquered the crisis through innovation, determination, and the willingness to abandon conventional wisdom when it proved inadequate. The bombers, rolling out of Willow Run, would soon fill the skies over Europe, but their true significance extended beyond their military function. They represented a fundamental transformation in how humanity could organize industrial production, a revolution that would reshape the post-war world in ways that no one yet fully understood. The spring of 1944 brought a transformation to the skies over Europe that German military commanders could no longer deny or rationalize. American bomber formations now appeared with a regularity and strength that defied every pre-war calculation. On a single day in April, over 1,200 heavy bombers struck targets across Germany, a number that exceeded the entire Luftwaffe bomber force at its peak. The impossible had become routine, and the psychological impact on German forces was devastating. General Lieutenant Adolf Galland, one of Germany's most decorated fighter aces, and now General of the Fighter Arm, stood in the operations room at Luftwaffe headquarters, studying reconnaissance photographs with mounting despair. The images showed American bomber formations so large that they appeared as solid masses on the prints. His fighter squadrons were being overwhelmed not by superior tactics or technology, but by sheer numerical superiority. "We shot down 63 bombers yesterday," Galland reported to Reichsmarschall Göring during a tense meeting in late April. "Our pilots performed magnificently, yet today the Americans returned with even larger formations, as if yesterday's losses never occurred. We are destroying them faster than we ever thought possible, and it makes no difference." Göring, his confidence finally shattered by undeniable reality, demanded answers. "Where are these aircraft coming from? Our intelligence assured us that American production capacity was limited. How can they replace losses overnight?" The answer arrived in the form of a captured American airman, a B-24 pilot named Captain James Morrison, shot down during a raid on Munich. During interrogation, Morrison mentioned almost casually that his bomber had been manufactured at the Ford plant in Michigan. The German intelligence officer conducting the interrogation initially dismissed this as confusion. Surely the pilot meant his aircraft had been built by an aviation company and equipped with Ford engines, but Morrison insisted. "No, the whole plane was built by Ford at Willow Run. They're making them faster than we can fly them over here, one every hour around the clock." The interrogator, Major Ernst Hoffmann, included this claim in his report with a notation: "Prisoner appears to be repeating propaganda designed to inflate American capabilities. Recommend psychological evaluation." But Hoffmann couldn't entirely dismiss the statement. It aligned too perfectly with the inexplicable bomber numbers appearing over Germany. The report reached Oberst Heinrich Wegener, the intelligence analyst who had been marginalized 18 months earlier for suggesting that American production exceeded German estimates. Wegener, now working in a minor administrative role, read Morrison's statement with grim vindication. He compiled every piece of evidence accumulated over the past 2 years: reconnaissance photographs, production estimates from neutral sources, technical analysis of captured aircraft, and prisoner statements. The conclusion was inescapable and catastrophic. Wegener's new report, submitted in May 1944, painted a picture of industrial capacity that seemed to belong to science fiction rather than reality. According to his analysis, the Ford Motor Company's Willow Run facility was producing B-24 Liberators at a rate of 1 per hour, 8,685 aircraft per year from a single factory. This exceeded the total annual production of all German bomber types combined. And Willow Run was just one of several American facilities producing heavy bombers. "The Americans have achieved what we believed impossible," Wegener wrote in his conclusion. "They have industrialized warfare to a degree that renders traditional military calculations obsolete. We are not fighting an air force. We are fighting an industrial system that can generate aircraft faster than we can destroy them. This is a war we cannot win through attrition." The report circulated through the highest levels of German command, and its implications were too stark to ignore any longer. Albert Speer, the armaments minister, who had once dismissed American manufacturing capabilities, now confronted the reality of his miscalculation. In a private meeting with Hitler in June 1944, Speer delivered an assessment that bordered on defeatism. "The American industrial advantage is insurmountable," Speer stated bluntly. They have applied mass production techniques to military equipment in ways we never imagined possible. A single American factory produces more bombers in a month than our entire aviation industry produces in a year. We lack the resources, the workforce, and the time to match their output. Hitler, increasingly detached from reality, refused to accept the assessment. German quality will triumph over American quantity, he insisted, repeating a mantra that had lost all connection to the war's actual conditions. But even Hitler's denial couldn't change the mathematics of industrial warfare. The psychological impact on German forces was profound and multifaceted. Luftwaffe pilots, once confident in their superiority, now flew missions with the knowledge that they were fighting an unwinnable battle. Lieutenant Franz Stiegler, the fighter ace who had first reported unusually large American formations in 1943, shot down his 42nd Allied aircraft in May 1944. It should have been a moment of celebration. Instead, he wrote in his diary, "I have killed 42 men, and it means nothing. Tomorrow there will be 100 more bombers, and the day after, 100 more. We are drowning in American steel." German civilians, subjected to increasingly devastating bombing raids, began to understand that their government's assurances of eventual victory were hollow. The bombers came in daylight now, in formations so large that they blotted out the sun. The Luftwaffe's attempts at interception seemed futile, like throwing stones at a flood. Cities that had survived years of war were reduced to rubble in hours. The psychological message was clear. Germany faced an enemy with inexhaustible resources. In June 1944, as Allied forces landed in Normandy, the skies above the invasion beaches were dominated by Allied aircraft. The Luftwaffe, which had once terrorized Europe, managed only token resistance. German ground forces, promised air support that never materialized, fought without the cover that had been fundamental to their early war successes. The absence of German aircraft over Normandy was not due to lack of courage or skill. It was due to simple mathematics. The Luftwaffe had been bled white by months of attrition against an enemy that could replace losses faster than Germany could inflict them. A captured German officer, Oberst Wilhelm Bauer, provided a statement during interrogation that perfectly captured the demoralization spreading through German ranks. "We were told that Americans were soft, that they lacked the discipline and industrial capability to wage modern war. We were told that their production figures were propaganda. Now we know the truth. Every hour, while we struggle to produce a single fighter aircraft, the Americans complete a 4-engine bomber. How do you fight an enemy like that? How do you maintain hope when the mathematics of war are so completely against you?" The Willow Run bombers, identifiable by their consistent construction quality and Ford manufacturing stamps, became symbols of American industrial might. German propaganda attempted to portray them as evidence of American materialism, quantity without quality. But the bombers' performance contradicted this narrative. They flew as well as hand-built aircraft, carried the same bomb loads, and survived combat damage with remarkable resilience. The Ford assembly line had not compromised quality. It had democratized excellence. By the summer of 1944, German military planners were conducting assessments based on a new and terrible reality. The question was no longer how to achieve victory, but how to avoid total annihilation. The industrial disparity between Germany and the United States had become so vast that traditional military strategy was irrelevant. Germany was fighting not just against Allied armies, but against the productive capacity of an entire continent mobilized for war. In August 1944, General Lieutenant Galland submitted a report that recommended withdrawing all fighter aircraft from Western Europe to defend the Reich itself. "We cannot contest the skies over France," he wrote. "The Americans have achieved air superiority through industrial supremacy. Our only option is to concentrate our remaining forces for the defense of Germany's vital industries and cities. Even this may prove futile. but it is our only rational course of action. The recommendation was implemented, but it came too late. The damage to German industrial capacity was already catastrophic. Factories that had taken years to build were destroyed in hours. Skilled workers who could not be replaced were killed in bombing raids. The transportation network that connected Germany's industrial regions was systematically dismantled from the air. And every day, more bombers arrived from England, many of them bearing the mark of Willow Run's assembly line. The German soldiers who had once marched confidently across Europe now looked to the skies with dread. The sound of aircraft engines, once a source of pride when they belonged to the Luftwaffe, now signaled destruction. The psychological transformation was complete. Germany had gone from aggressor to victim, from confidence to despair, and the instrument of that transformation was industrial capacity that they had fatally underestimated. In the ruins of German cities, in the desperate reports from military commanders, and in the private diaries of soldiers who knew the war was lost, a common theme emerged. They had been defeated not by superior soldiers or brilliant strategy, but by factories, specifically by a single factory in Michigan that had achieved what German engineering doctrine insisted was impossible. The war would continue for another year, but its outcome was no longer in doubt. Willow Run had helped seal Germany's fate, one bomber per hour relentlessly, until victory was inevitable. The final B-24 Liberator rolled off the Willow Run assembly line on June 28, 1945, 2 months after Germany's surrender and weeks before Japan's capitulation would end the war entirely. The bomber, serial number 44-52400, was the 8,785th aircraft produced at the facility in just under 3 years of full-scale operation. Workers gathered on the factory floor for a ceremony that was simultaneously celebratory and melancholic. They had achieved the impossible, and now their achievement was no longer needed. Charles Sorensen, now 64 years old and exhausted by the war years, stood before the assembled workers and delivered remarks that captured the magnitude of what they had accomplished. "You were told this couldn't be done," he said, his voice carrying across the vast factory floor. Aviation experts said that bombers couldn't be mass-produced. Military planners doubted that automotive techniques could be applied to aircraft. You proved them all wrong. You didn't just build bombers, you revolutionized manufacturing itself. The statistics were staggering. Willow Run had produced 8,785 B-24 Liberators, representing approximately 18% of all American bomber production during the war. At peak efficiency in 1944, the factory had sustained production rates exceeding 1 aircraft per hour for months at a time. The facility had employed over 42,000 workers at its height, including thousands of women and minorities who had been excluded from skilled manufacturing jobs before the war. The total value of aircraft produced exceeded $6.7 billion in 1945 dollars, equivalent to over $100 billion in modern currency. But the numbers, impressive as they were, told only part of the story. Willow Run's true legacy lay in what it had proven about the nature of manufacturing innovation and human capability. The factory had demonstrated that complexity could be conquered through systematic organization, that traditional craft-based production could be transformed into continuous flow systems, and that seemingly impossible goals could be achieved through determination and creative problem-solving. The military impact was equally profound. The B-24s produced at Willow Run had flown over 200,000 combat missions, dropped more than 450,000 tons of bombs on Axis targets, and contributed decisively to the strategic bombing campaign that crippled German industrial capacity. Air Force historians would later calculate that Willow Run's production had shortened the European war by an estimated 6 to 9 months, saving countless lives and preventing further destruction. General Henry Hap Arnold, in his post-war memoirs, wrote, "Willow Run represented more than aircraft production. It represented the industrial might that made Allied victory inevitable." When historians ask how we won the war, part of the answer will always be, we outproduced the enemy to a degree that made their defeat mathematically certain. The human stories behind the statistics were equally compelling. Rosemary Colt, the young metallurgist who had established the aluminum fabrication process during the supply chain crisis, went on to earn a doctorate in materials science and became a professor at MIT, where she trained a generation of engineers in advanced manufacturing techniques. Her wartime innovations in rapid metal forming became standard practice in the aerospace industry. Logan Miller, the plant manager who had made the split-second decision to activate the carbon dioxide fire suppression system, received the Medal for Merit, the highest civilian decoration awarded during the war. He later served as a consultant to the United Nations, helping war-torn nations rebuild their industrial infrastructure using principles developed at Willow Run. Mildred Hatcher, the former telephone operator who had feared her electrical work might kill bomber crews, discovered a talent for complex systems that she never knew she possessed. After the war, she became one of the first women hired as an engineer at General Electric, where she contributed to the development of jet engine electrical systems. Willow Run taught me that I was capable of far more than society expected from a woman, she reflected in a 1985 interview. It changed not just what I did, but who I believed I could be. The factory's impact on social progress was as significant as its industrial achievements. Willow Run had employed over 25,000 women in roles traditionally reserved for men, demonstrating that gender was irrelevant to manufacturing capability. African-American workers, recruited from the South to fill labor shortages, proved equally capable despite facing discrimination in housing and services outside the factory. The integrated workforce, while not without tensions, provided a preview of the social changes that would transform America in the decades following the war. The German prisoners of war, who had been brought to Willow Run in 1944 as part of a psychological warfare program, returned to Germany with stories that seemed like fantasy. They had witnessed American industrial capacity firsthand, watching bombers emerge from the factory at intervals that defied belief. Many of these former prisoners became advocates for democratic capitalism during Germany's reconstruction, arguing that the Soviet model of centralized planning could never match the innovative efficiency they had witnessed in Michigan. Franz Stigler, the Luftwaffe ace who had documented his despair at fighting an unwinnable war of attrition, survived the conflict and emigrated to Canada in 1953. He eventually met Charles Brown, an American B-24 pilot whose damaged bomber, Stigler, had chosen not to shoot down during a chance encounter over Germany in 1943. The two men became close friends, and Stigler often spoke about the psychological impact of facing an enemy with seemingly infinite resources. "We were brave, we were skilled, but we were fighting mathematics," he would say. Willow Run was the equation that proved we couldn't win. The factory itself underwent a transformation that reflected the changing nature of American industry. After a brief period of uncertainty about its post-war purpose, Willow Run was converted to automobile production, manufacturing Kaiser and Fraser vehicles. Later, General Motors acquired the facility and used it for various automotive purposes until 2010. The building, that massive structure that had once been the largest room under one roof in the world, stood as a monument to American industrial achievement for 7 decades. In 2013, preservationists fought to save a portion of the original factory from demolition. The campaign succeeded in preserving 144,000 square feet of the structure, which became the home of the Yankee Air Museum. Visitors can now walk through a small section of the assembly line where history was made, though the vast majority of the building was demolished to make way for a modern automotive testing facility. The irony was not lost on historians. A factory that had revolutionized manufacturing was itself replaced by the next generation of industrial innovation. The technical innovations developed at Willow Run influenced manufacturing practices far beyond aviation. The continuous flow production techniques, the integrated supply chain management, the predictive maintenance systems, and the quality control protocols became standard practice across American industry. Japanese manufacturers, studying American production methods during their post-war reconstruction, incorporated many Willow Run principles into what would later be called lean manufacturing and just-in-time production. Perhaps the most profound legacy was philosophical rather than technical. Willow Run had proven that audacious goals, even those that seemed to violate established wisdom, could be achieved through systematic effort and creative problem-solving. The factory became a symbol of American optimism and capability, a reminder that limitations were often self-imposed rather than inherent. Charles Sorensen retired from Ford in 1944, his health broken by the stress of the war years, but his reputation secured by Willow Run's success. He spent his final years writing his memoirs and consulting with manufacturers seeking to apply the lessons learned during the war. He died in 1968, having witnessed the transformation of manufacturing that he had helped pioneer spread across the global economy. In his final interview, given just months before his death, Sorensen reflected on the Willow Run experience. "People ask me if I knew we would succeed. The truth is, I didn't know. No one knew. We were attempting something that had never been done, solving problems that had never been solved. But we had something more powerful than certainty. We had necessity, determination, and the willingness to fail and try again. That combination can accomplish anything." The B-24 Liberators produced at Willow Run are now museum pieces, carefully preserved examples of a bygone era of aviation. But their significance extends beyond their role as weapons of war. They represent a moment when human ingenuity, industrial capacity, and national will converged to achieve something that changed the course of history. They are monuments to the workers who built them, the engineers who designed the systems that made their production possible, and the vision that dared to imagine that the impossible was merely difficult. The German prisoners who stood at the fence in 1944, watching bombers emerge from the factory at one-hour intervals, had witnessed more than industrial production. They had witnessed the future. A world where manufacturing capability would determine national power, where innovation would trump tradition, and where the willingness to challenge conventional wisdom would separate success from failure. Willow Run was not just a factory. It was a revolution, and its echoes continue to resonate through every modern manufacturing facility that dares to pursue the impossible. The story of Willow Run reminds us that the greatest achievements often begin with someone declaring that the impossible is merely a challenge waiting to be solved. From the skepticism of 1941 to the triumph of 1944, this factory proved that human determination, combined with innovative thinking, can overcome any obstacle. If you found this journey through history as compelling as we did, subscribe to our channel for more untold stories of innovation, courage, and the moments that changed our world. Share your thoughts in the comments. What modern challenge do you think demands the same audacious spirit that built Willow Run? Hit that notification bell, because history's most fascinating stories are still waiting to be told, and we're just getting started.